Okay, so we're going to go through the 2021 Algebra paper. This is the E version, the Thursday version. So question 1 should be reasonably straightforward. The perimeter is just the sides added together. So the expression here, and that adds 35. Simplifying, we get 6y plus 5 equals 35. Solving, we get y equals 5 centimeters. Achieved question. Second question, we're solving an inequality. The process is exactly the same as solving for an equation. So we expand the brackets first on the left and the right. Then the 8x squared cancel out. Simplifying on the left, we get 2x minus 3. On the right, we get minus 15x minus 2. Add 15x to both sides. Add 3 to both sides. And divide both sides by 17. We get x is larger than or equal to 1 over 17. So just follow the same process as if it was solving for an equation. But instead of writing equal sign, you've got the inequality sign. Next question is a simultaneous equations question. The rectangle on the left has a perimeter of 6g plus 8h, 3g plus 3g plus 4h plus 4h, and that adds to 20. So one equation is 6g plus 8h equals 20. Second rectangle, we've got 8g plus 10h equals 26. That's the perimeter of the second rectangle. Now let's take our this second equation and let's rearrange it to make h the subject. So subtracting h here from both sides, we get 10h equals 26 minus he, and then dividing both sides by 10, we get h equals 2.6 minus 0.8 he. And what we can do is we can take this equation here, h is equal to this, and put that into our first equation. So that's what I'm doing here. I'm taking equation 1, and I'm replacing h with 2.6 minus 0.8 g. That's all I'm doing there. And then that equals 20, and then expanding the brackets, we get this. Simplifying, we get this. We subtract 20.8 from both sides, and then divide both sides by negative 0.48, g equals 2. And then we put g back into this equation for h. We get h equals 1. And then we use g and h to work out the dimensions of the rectangles, because the question asks us for the length of both the rectangles. So a is 3g by 4h, which is 6 centimeters by 4 centimeters. B is 5h by 4g, which is 5 centimeters by 8 centimeters. Okay, next question. Solving an equation. So we want to clear the fractions first. We can do that by multiplying both sides by 12. This first fraction, we're multiplying by 12 and dividing by 4, which is the same as multiplying by 3. So we get 3 times y plus 3. The second fraction, we're multiplying by 12 and dividing by 3, which is the same as multiplying by 4. So we get 4 times 2y minus 3, and that equals 12 times 2, which is 36. Expanding the brackets, we get this. Simplifying, we get this next line. Subtract 21 from both sides, we get this line here. Divide both sides by negative 5, we get y equals negative 3. Okay, this question here, so we've got a flower bed in the middle, and the area of the whole backyard is double the area of the flower bed. Now the flower bed has 9 by 6 meters and 54 meters squared, so therefore the area of the whole backyard is double that, which is 108 meters squared. Now, if we look at it along the bottom or along the side, we've got x plus 9 plus x. So that's 2 lots of x plus 9 across the whole width, so that's 2x plus 9. Going vertically, we've got x plus 6 plus x, which is 2 lots of x plus 6, so that's 2x plus 6. So the whole area is base times height, which is 2x plus 9 times 2x plus 6, and that equals 108. So that's our equation that we've formed there. 2x plus 9 times 2x plus 6, base times height equals 108. Expanding the brackets, simplifying, we get this. Subtracting 108 from both sides, we get this. Dividing both sides of the equation by 2, we get this. And then we've got a quadratic which we can solve. I've shown the process for solving it here. But we end up getting x equals negative 9 or x equals 3 over 2. Now, x is a length, right? So obviously it can't be negative, therefore x will be equal to 1.5. That's our final answer. Okay, question 2, we've got a square with lengths 4y plus 7. So that area is 4y plus 7 times 4y plus 7, which we expand. We get this, and simplifying we get this, and that's in the form that we want it to be in. Next question, when we multiply two terms with powers, we keep the base the same and we add the powers. So 2 to the power of 2y times 2 to the power of 2y minus 12, we add the powers, we get 2 to the power of 4y minus 12. Now this is a mistake, sorry, this on the right should say 2 to the power of 4. Ignore that 4, that's actually a mistake. It should have the same thing there as it does up here, which is 2 to the power of 4. So I'm writing 16 as 2 to the power of 4, and you'll see why I do that in a moment. Because if 2 to the power of 4y minus 12 equals 2 to the power of 4, remember this here should say 2 to the power of 4, then what we're going to have is 4y minus 12 equals 4. The powers have to be the same. The bases are the same, right? 2 to the power of this equals 2 to the power of 4. Therefore, the powers must also be the same. So we get 4y minus 12 equals 4. It's a simple linear equation you can solve, and we get y equals 4. Okay, next question. Bit of a tricky one here. We're going to start by, to add these two fractions, we can use cross multiplication. So we go 3 times y plus 4 minus 3 times y minus 4. And that's what I've done here. 3 times y plus 4 minus 3 times y minus 4. And we multiply the bottoms together. Y minus 4 times y plus 4, and leaving the right hand side the same. Simplifying on the left, we get this. And further simplifying, we get this. Then we can cross multiply on both sides of equals, so multiplying both sides by y plus 1, multiplying both sides by y squared minus 16. Then expanding the brackets, we get the next line. Getting everything on to the right hand side, we get this. Dividing both sides by 2, we get this. Factorizing, we get this. And then our solutions are 14 or negative 2. Okay, next question, simplifying as far as possible. So the top quadratic we can simplify to x minus 2 times 3x plus 4. The bottom quadratic we can simplify to 3 times x plus 2 times x minus 2. For our rational expression, our fraction, we can write as x minus 2 times 3x plus 4. 3 times x plus 2 times x minus 2. Then the x minus 2's cancel out on the top and the bottom, and we get the fraction here. Okay, another question. So the total area is 10 meters squared, and the length of all the black lines total is 16 meters. So if we look at the length of the black lines, we've got three lots of x, 3 lots of x, plus 2 lots of y, and that adds to 16. So that's our equation there. If we make y the subject of that equation, we subtract 3x from both sides, divide both sides by 2, we get y equals 8 minus 1.5x. And we also know the area is 10, so that therefore base times height, x times y equals 10. Now what we can do is we can take this equation here, number 1, and substitute it into equation number 2, this equation up here. So replacing the y with 8 minus 1.5x, we get x times, instead of y, we write 8 minus 1.5x, and then equals 10. Expanding the brackets, we get this. Doing everything on the right hand side, we get this. Multiplying both sides by 2 to get whole numbers, we get this. Then we've got a quadratic which we can factorize to solve. We end up getting x equals either 2.33 meters or 2 meters. Good solutions. Question 3. Substitution question first up. So we're just replacing y with negative 3 and x with 2. We get 51 as our answer. Next, this quadratic has two solutions. To solve a quadratic, we get everything on one side, so let's get 5 onto the right hand side. This is our quadratic with everything on the same side, that equals 0. Then we're looking for, we go through a process of solving, and we get, we'll factorize, we get this. And then either x minus 5 equals 0 or 3x plus 1 equals 0. For our solutions are 5 and negative 1/3. The solutions are a and b, with a being larger than b. So for a is 5, b is negative 1/3. A minus 2 is 5 minus negative 1/3, which is 5 and 1/3. Okay, find the values of the numbers c and w that will make this side equal to this side. So we just expand the side on the left to get 9x squared plus 6bx plus b squared. Then equating coefficients, the 9x squared is the same on both sides. The coefficients of x are 6b and w, therefore 6b must equal W, and we must have this V squared equals 16. Therefore V equals 4. V has to be a positive number, so it can't be a negative 4, just positive 4. And then I've got 6V equals W, W equals 6V, W equals 24. The next question, we can turn this into a quadratic by making x equal to g squared. So then we can rewrite this equation in terms of x. Okay, so if x is equal to g squared, then g to the power of 4 will be the same as x squared. Right, x squared will be this g squared squared, and if we get g squared and multiply it by itself, we get g to the power of 4. So x squared is the same as g to the power of 4. Negative 8g squared, we can write as negative 8x because we've replaced g squared with x, and we've got plus 16 equals 0. Factorizing that, we get x minus 4 times x minus 4 equals 0, x equals 4. X is equal to g squared, which means g squared equals x, g squared equals 4 because x equals 4, therefore g is equal to plus or minus 2. Alright, last question. We're trying to write an equation for what q is equal to. So we start by multiplying both sides by p minus 3q. So multiply both sides of the equation by p minus 3q. That cancels out on the right. On the left we get t times p minus 3q. Expanding the brackets we get this. Then let's get everything with a q on the left. So adding 6q to both sides we get this next line. Let's get everything without a q on the right hand side. So subtracting pt from both sides we get this next line. And then what I've done also from here to here is I've just switched the order of these around. I've got negative 3t plus 6q is the same as 6q minus 3t. Then I'm factorizing to take out q. So taking out the q, and then I'm going to have 6 minus 3t in brackets. And then last step is to divide everything on both sides by the 6 minus 3t to cancel out the multiplication on the left and leave me just q on the left. And 7p minus pt divided by 6 minus 3t on the right. And that's the end of the page.